So I'm trying to see something over there, and I don't want those guys to see me over here. Now, you guys know that I could just fly a drone over there. That's a great way to see stuff that's far away, but it's also a great way for your drone to get seen. Sometimes you want a slightly more passive observation device. And so in this episode, we're going to be comparing some different long-range intelligence gathering tools, some that you might obviously think of and some that you might not. Okay, here's the scenario. That piece of paper over there, that tiny white dot, is 8.5 by 11 piece of paper, and it's got some writing on it. And I need to read that writing. So we're going to experiment with some different optics here. According to this laser rangefinder from Vortex, that is 142 meters away, which is not very far, but some of the text is really tiny. So I think this is going to be a pretty stringent test. Now, the first thing that I'm going to do is look at it with my eye through this 20 power spotting scope. But the human eye sometimes isn't enough. There's a lot of times when you want to observe and you want to be the one seeing what's going on. But a lot of the time you actually need to be able to record. Intelligence gathering often means recording the data. So the best thing that I can do with this particular spotting scope is probably film through it with my cell phone. We'll try to experiment with that. And then the next thing we're going to try is a device that is a little bit more designed for capturing video and images with a sort of an experimental lens setup on here, something that is both light and affordable. So these are the two main things that are going to go head to head, but we've got a couple of other ideas that we're going to try as well. So first thing first, this $150 cheap spotting scope with 20-time magnification. Let the record show that with my human eyeball and these optics, I can read the first 4 lines of the text. I cheat a little bit on a couple of words because I already know what it says. But the main obstacle that we have to defeat right now is the heat mirage coming off of the road, signs on the other side of the road. I'm curious to see whether I can get that much detail with my phone. Now, you've probably tried to hold your phone up to various scopes and optics, and it works, you know, kind of sort of well. Now, it should work better than this, because one of the beauties of these teeny tiny phones with their teeny tiny cameras and their teeny tiny lenses is it is a little bit close to that human eyeball. So ideally, especially when you're shooting something really far away, you want to have some sort of adapter holding that thing really stably. I don't know what brand this is because it came with the super cheapo spotting scope, but I actually think this is a relatively clever design, and it can clamp down on a bunch of different sized eyepieces. And yeah, it'd be sturdier if it were made out of metal, but plastic is cheap and lightweight, and if I don't touch it, we should be able to get decent results. So I'm more or less lined up on this particular lens here, but it's more less than more. As you can see, I can see this whole circle here. This is the 1 power lens, which is the main camera for most phones. But fortunately, this is the Samsung 22 Ultra, which means it's got a whole bunch of different cameras and a whole bunch of different lenses. I think that for our purposes, the number 3 lens, the 3 times power lens, is going to give us a better shot. This is very finicky, but I believe that we have got it. As good as we're gonna get it. This is a 3 times zoom on the phone going through the 20 times zoom on the spotting scope, and the image is relatively clear. There's some chromatic aberration coming from the spotting scope lens. Got us aligned as good as we can get, and yeah, there's just an awful lot of heat wave. But I think that I can make out that 4th line. That's honestly working a little bit better than I expected. What we're looking at here is about 150 bucks for the spotting scope when you buy the cheapest possible one from Amazon, and it came with the free phone adapter, and then the phone is about 1,000 bucks. I bought it used, so it's less, but new it's more. So for scorekeeping purposes, let's say $1,000 to record this image. Now, let's shift to something that is a little bit more specific. This right here is the Sony ZVE1. This is a camera that is designed to shoot 4K video, and it does so with a really nice sensor and a huge amount of sensitivity. Not a ton of actual resolution, because this is a video camera first and a still camera second, but for a lot of intelligence gathering purposes, you want video more than stills, and this thing is a just under $2,000 camera. And on the front of it, I have put a roughly $100 lens. Now, there's a couple of different ways to do lenses. If you want to get technical and photographic and cinematical, there's lots of lenses. There's rectilinear and there's spherical and there's anamorphic, but never mind all that. There's basically two kinds of lenses for our purposes. There are glass lenses, like the one that is inside of the spotting scope, and then there are reflex lenses, like this one, where there is no glass, there are only curved mirrors. And as a result of that, this is actually an incredibly light lens. There's no lenses in here, 2 mirrors that weigh almost nothing, a metal housing, and $100 for this lens. Mirrored lenses or reflectors are rare in photography, but they're very common in telescopes, especially giant observatories, because the bigger the telescope is, the better that mirror is going to do at reflecting light.
The big mirror essentially is like a big bucket. It collects all the light as it's traveling through space, and then they focus that down. They wanted as big of a mirror as possible because that means they can get more light, a bigger bucket. So all this light reflects off that big concave mirror and is focused down onto the little secondary mirror in front of it. Think about it, that is so much more light hitting that little mirror than if the little mirror was just looking out into space by itself.
Also, a giant glass lens would be incredibly thick, and it would actually absorb a lot of photons and transmit fewer of them. So that is why. The smaller you go, on the other hand, the better the glass lenses do, because they will outperform the surface imperfections that you would get on a small mirror. So at this size, it's kind of hard to say which one is going to have the edge. So the worst part about this lens is the fact that it is a manual focus lens, and it's difficult for me to focus without bumping the camera, but we are at 500 millimeters on the lens and then a doubler, so we're at 1,000 millimeters of magnification, at which point we are able to see the sign. Now, I think that we're going to run into some of the same issues that we've run into with the spotting scope. The actual air quality is degrading the image more than the optical quality of this lens, probably more than the mirror quality of this lens. We're zoomed in, we're recording 4K footage, and I'm really curious to get that onto a screen and compare the two. But this thing does have some significant advantages over the spotting scope. So the first one is that when you're using this camera, you are using something that is a lot easier to move around and carry and throw into a backpack, even as is, than this thing with the phone kind of kludged onto it. So my recommendation for you guys is, if you know for sure that you're going to be capturing images and video, to think about the full setup, not just how it sits on a tripod. The other thing that's really interesting about this is because it is so short and light, especially if you go back to 500 millimeters and you get rid of the extension tube, is you manage to have something that is incredibly compact and doesn't draw a whole lot of attention. Now, in the past, these reflex lenses have been pretty lame because they don't have that beautiful cinematic quality. People have looked down their noses at these things because they don't shoot the fantastic images that your, wedding photographer is supposed to be delivering to you. Snooty photographers love to obsess over good glass, and especially little things like bokeh. Bokeh!
Bokeh.
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 Bokeh?
Bokeh.
Yeah.
Bokeh is the right answer.
Bokeh is, of course, the out of focus elements right here, which are a product of the aperture and the depth of field that a lens can produce. And long, bitter forum wars have been fought over this stuff. The only thing that photographers really agree on is that reflex lenses have this really weird donut bokeh, and nobody likes it. The other reason they aren't used much for cinematic stuff is that super long focal lengths, they're just weird. You really don't use them in movies except for two specific shots: sunrise on the savannah and sunset on the deserted island behind the small shipwrecked boy. That's it. Those are the only two real applications. They're actually far more suited to wildlife photography for documentaries.
This young male has quick reflexes. He wets his beak and improves his kill-death ratio once more.
I actually did shoot a wedding with this thing at super long ranges without telling anybody, just for science. We're not going to show anybody's faces. Hopefully it's not too creepy. And I was able to shoot surprisingly late into the night with this f6.3 lens. You can see that it's definitely soft, and it definitely has some strange blemishes and some interesting artifacts, and it's a very low contrast lens. It definitely has its own very strange look. When it comes to pure zoom capability and pure information gathering capability, this thing is actually pretty neat. And in the past, long zoom lenses that were made out of optical glass that get very big and heavy and expensive had an advantage in that they could be stabilized. There would be little stabilizers attached to some of the lens elements so that you could zoom in and get a slightly better image. Modern cameras have the ability to stabilize the sensor back here, which means that even though this thing is not stabilized or electrified or motorized in any way, I can stabilize the image here by moving the sensor, and I can stabilize the image digitally by stabilizing the image before I record it. At 500 millimeters, I can shoot handheld, and I can track moving vehicles from moving vehicles. Now, to be fair, it is not the silky smooth cinematic motion that Michael Bay wants, but it is very impressive for such a cheap and tiny setup. And while a lot of these shots are kind of jerky, like the pans, I can still hold pretty still, and individual frames are sharp, and we can definitely get useful info here, even if cinematography snobs like me have some minor issues with it. Now, while we're talking about the Sony ZV-E1 for a moment, I just want to say this is a fantastic camera. It might be my favorite ever. All the T.Rex Labs content and a bunch of T.Rex Arms content has been shot on this thing. That one is one of these things right there. It has a bunch of interesting features. It's designed to be a vlogger camera, but I don't hold that against it. It's missing a few features like a mechanical shutter, which is something that a photography camera needs, but a video camera doesn't. It's also missing a viewfinder, which is a little bit of a pain for some of our surveillance purposes. This screen flips out and you can look at it from all different directions, and that's pretty cool, but if we wanted a little more light discipline, there's no viewfinder. We'd have to get one of these little loop devices and stick that on there so that we could control what light is coming off of the screen. And there's two kinds of these. There's the kind that are made out of soft rubber, and you can squish those down for storage. That's kind of nice. And then there's the kind that are hard rubber that you can't squish down, but then you have an extra little bit of support, an extra point of contact when you're stabilizing this. So, you know, your mileage may vary, get whichever one that you want. But there's a lot of stuff that you can do with this little camera here. You can stream over USB, you can stream over Wi-Fi, you can do a whole bunch of interesting observational data gathering type stuff with this camera in real time that is, I think, a little bit of a game changer over, you know, previous surveillance tools. Now, there is something else that I would like to try. Remember how I mentioned that this Samsung has a ton of extra lenses? It has a 1x zoom, it has 3x zoom, and then it has wide angle down here. But this thing is a 10x optical zoom. So let's see how that does on the tripod here. Now the letters that we're looking for start at 2 inches tall, then 1.5, then 1, then 0.5. And at that distance, yeah, I can see the paper pretty clearly. Let's see what we can see at 10x zoom here. It is relatively tiny still. Now we can digitally zoom in on this particular image, and we can go all the way to 100. We can easily see that top line, but I gotta be honest, if I didn't know what it said, I don't think I could read it. That is a 100x zoom. 10 of that is optical, which looks like this, and 10 of that is digital. Let me switch to video mode and get a little bit better quality here. I'm gonna be recording this video at the maximum bit rate and quality. and we'll see if we can read any of that text through the haze. It does kind of line up with the spotting scope. This right here is supposed to be 20 power, and that is roughly what this looked like through the 1 power lens. The 10 power zoom lens on the S22 Ultra is equivalent to a 230 millimeter lens on a full frame camera like the Sony, so about half of the 500 millimeter reflex. And so, you know, that's not amazing in comparison, but that is a massive zoom for such a tiny phone. That means this is the most covert observation device, even if it doesn't have the most reach. So we got to cover these guys' faces because they are 100% identifiable even at this long range. And that 200 millimeter zoom range is actually quite good for nature documentaries.
The pelican is an ugly bird, ungainly and bad-tempered. It serves no purpose but to remind people of the infantile poems of Ogden Nash. They should all be destroyed.
Okay, there's one more thing I want to try. You know those ads for little phone telescopes that look amazing on Instagram, but you know in real life they're terrible? Let's give that a shot. So that is, oh, this is super finicky. It's unbelievably fragile feeling, but it actually works a little better than I thought. That's an 18 power zoom on the 3 power camera. So yeah, I don't think we're gonna be able to read anything, but better than I thought. And I just realized one more test we can do. In case you guys were worried about the optical and build quality of this $100 El Cheapo spotting scope, this is a Leopold. It is $1,000. This carbon tripod is possibly the most expensive thing that we have out here. Let's give this one a shot. So first of all, I can cheat by cranking it up to 40 power zoom, which is double than we had before, and I can absolutely see with my eyeball an easier to read image. Now I can't see any more text than I could before. The mirage is still the biggest issue that I am dealing with. So I can see the text more clearly that I could read before, but I can't read the line that is under it. In order of is the last, or in order to, what does it say? In order to. Yeah, in order to is the last thing that I can read, but I am zoomed in twice as much as last time. So for the sake of being fair and accurate, we'll do this. Okay, the eye relief on this scope is a little bit different than the others. I'm just trying to put the image in the sweet spot and get the focus right. Even though this is a much better scope with much better glass, the eyepiece doesn't like the adapter as much. So I am never going to look down my nose at expensive glass or say that it's inferior to the really cheap stuff. But occasionally there are other factors. The mirage is obviously an issue, and even just the way that this adapter interfaces with this eyepiece is not quite as solid as on the bad scope. So even though this is better glass, you're gonna kind of have to trust me on that, or at least for now. As we were shooting this video, we talked about it, we realized that our chart, even though we told you the heights of the letters, is not super practical. What's more practical is license plates. I actually use license plates for testing distances and ranging and stuff all the time, but rather than use somebody else's license plates, we put our own fake license plates down there, 3.5 inches license plate font, and we put them out at some different distances, 100, 200, 300. We're gonna go up there, we're gonna see how well we can see them. All right, I have got the spotting scope dialed in. We have our license plates, 100 meters, 200 meters, 300 meters. That's 3.5 inches tall text. And it's actually pretty easy to see it at 300 meters with this spotting scope here. So now let's try a smaller covert tripod on this guy. Yeah, the GorillaPod almost working, but not quite. I'm gonna switch to the proper tripod. This little lens mount adapter, which I cobbled together onto this thing, it's kind of failing. But fortunately, this whole lens assembly here is so light that I'm just gonna go off the camera and it'll be fine. Every time a vehicle goes by, kind of shakes. So that's making it hard for me to dial it in. We're right on the edge of what we should be able to do with this lens. And if I could mount this a little more securely, it would be working great. Let's get on the ground. This is definitely the limit of this lens. 1,000 millimeters on a full frame camera. If we had glass, if we had a very big, you know, extremely expensive, extremely heavy glass lens, we could totally see 400 meters. But we just don't have the sharpness with this lens. Just can't quite do it. So, 1,000 meter lens, full frame camera, ASPC crop, 300 meters. Doable for license plates, but we're right on the edge. You can't tell from there, but this is very bouncy and the stabilizer cannot quite keep up. It's not bad at 500, but at 1,000 millimeters, yeah, it cannot quite manage to absorb all these little bumps. And yeah, we're pushing this lens a little too far. So yeah, we pretty much maxed out this lens at 300 meters. 300 meters was pretty easy with this one. I think we could have hit 400 with my eye easily. We probably could have deciphered 400 meters with the phone, would have been right on the edge. So yeah, the difference is though, this is something that I can hand hold and stabilize out to maybe 200 meters, and this, it has to be on a tripod. There's absolutely no forgiveness for wobbles on this thing. The other advantage that the Sony camera has over our phone scope combo is low light sensitivity. All the footage so far has been in daylight, but as clouds blew in and the sun began to set, the phone started to lose detail fast. It has a very, very tiny sensor. And it gets very noisy when the full frame Sony camera was still looking really good. Obviously, the lens is still kind of soft, but as temperatures dropped, some of the mirage disappeared as well. And overall, it just retained image quality for a lot longer as it got darker. All right, it is now almost 15 minutes since the sun has gone down. You can see that the phone image is just so dark and grainy. I'm not even gonna bother putting it up next to the telescope. That's the main camera. It's the best camera. It's an f1.8 lens, just like the camera is, the Sony camera. And yet the Sony camera has way more sensitivity. The image is just phenomenal. I think we're about 40,000 ISO, and we could go to 400,000 ISO if we needed to. So way more detail, way more data being recorded in the dark. And we could turn that Sony camera into a full spectrum camera a lot easier than we could the phone. So as a intelligence gathering tool, yeah, definitely wins in the dark. So now that we're back inside in the air conditioning, we've looked at all of our footage. Every single pixel has been checked from everything that we have filmed. There is a clear and definitive answer as to which one of these things is better. And that answer is, of course, it depends. Obviously, if sheer zoom capability in broad daylight is all you need, this thing gives you more magnification. But if you want to shoot in the dark, you want to be able to record images and just have a lot more control over the camera itself, this thing is pretty cool. But there's another thing that I want to specifically bring up, and that is that this is not a super scientific test. There's actually a really good reason why. Ironically enough, here in T.Rex Labs, we actually don't care about laboratory results that much, and I'll explain why. You see, we're more concerned about real world results. The correct way to actually test lenses like this would be to have them in a controlled environment where environmental factors are not an issue and the lighting is managed a little bit better. But the other thing is we shouldn't really be comparing apples and oranges. We have a mirrored reflex lens on a full frame camera body over here, and then we have optical glass that's going to a super tiny little cell phone camera. So already we're kind of way off. But the goal here is not to really determine once and for all what is better, glass or mirrors, but to figure out what are the best tools for the job inside of roughly the same price bracket and roughly the same size and roughly the same weight. And also, just because I wanted to do this experiment, I've wanted to mess around with reflex lenses on film and video cameras for a while. So, now we get to do that. And I think the results are pretty interesting. If you do want to capture images from a long way away, there's a bunch of different ways that you can do it. So now you have a little bit more information. But getting to experiment and play with the gear is actually more important than some of the tests that we did. All that footage from the beach is stuff that I shot on vacation, just tinkering and playing with different things. And that is something that you have to do with your own gear. The fact that we got better results from this or from this at different times doesn't matter if you personally don't know how to use your own gear and aren't familiar and comfortable with it. And when you do that, you will learn some interesting things. For example, this optical doubler here, this teleconverter, is probably the weak link inside of this setup. I got really good results with 500 millimeters on the camera. And once I put the teleconverter on, I definitely had more zoom, but I had worse contrast. It was much harder to actually make this already finicky manual focus do the thing that I wanted. It wasn't actually strong enough. There was a bunch of extra flex that was introduced. And then mirrored lenses have a problem. They're the sharpest in the edges and they're the softest in the middle. It's the exact opposite of what happens with optical glass. Optical glass always has barrel distortion and softness in the corners, and it's sharp in the middle. But there's a problem here, because when you have your softness in the middle, your teleconverter zooms you right into the middle. So we actually are better off running this system with no optical doubler and just do a digital zoom in post. That's the best way to capture most of the data. And we tested that using not this video camera, but a Sony photo camera, the A7R III, which has tons of pixels, like 150 megapixels. So the main takeaway here is not that you need to get one of these or one of these. It might be that you need to get a slightly better phone and be a little bit more comfortable with it. I'm super impressed with this Samsung. Not only does it have a whole bunch of cool cameras on the back, but the really interesting thing about this particular camera is that 10x zoom that is right here. This is one of those skins from D brand. I think I'm the only YouTuber who is not actually sponsored by D brand, and here I am showing D brand skin. But this is the X-ray of the phone, and you can see that this 10x lens has this very fancy folded path periscope setup. That's the camera down there, and that is how they get 10 times optical zoom. Now, I'll just comment real quick. Why do we keep saying 20x zoom here and 5,500, 1,000 millimeters here? Well, they're not totally equivalent. This is the equivalent of a 230 millimeter lens inside of here, so roughly half of what this is doing, more or less. But 20x is basically just what your eye can see. Yeah, they're not the same. They're not the same units. So let's not get too worked up about those. Another really important point is that we're talking about drastically different sensor sizes here. The Sony camera has a gigantic full frame sensor. It is huge, it is gorgeous, it captures a ton of light. And focusing an image onto such a large sensor is a pretty serious job for a pretty serious lens. And then, on a cell phone camera, you have a sensor that's about the size of a grain of sand. So focusing an image down onto that requires much smaller, cheaper optics. That's why you can do it for $150 worth of glass pretty easily. Doing that with $150 worth of mirror is pretty cool. We could, if we wanted to better compare apples to apples, get a much better glass telephoto lens. But we're talking about a little bit more expensive package. Sigma is probably the cheapest way to do that for this camera, and I think that 500 millimeter range is going to get us close to $3,000. And then there are some really nice telephoto lenses that I have been looking at for a while. Canon has one. It's only $1,250 $5,000. But you know, there are also some downsides to it. It is going to be a much larger physical package, and it's going to weigh over 10 pounds. This is about a pound. This whole jury rig mounting system is about a pound. The camera is about a pound. So we have a huge amount of focusing and magnification capability in 3 pounds. That is really, really fascinating to do on a full frame sensor. I don't mean to take anything away from the miniaturization work done by Samsung here. Packing all of these cameras and their optics together in here is pretty fantastic, but I do have some bad news for you. This is the S22, the S24 and future Ultra Samsung phones are not going to have that 10x zoom anymore. They're going to top out at 5x, which probably works better for people who are doing basic phone photography, but I think it's a really interesting bit of surveillance or basically observational technology. I mentioned that it was extremely covert. You can do a lot with a little. You can get one of these little pocket tripod-y things, and you can set this thing down, and it looks like you're just watching a movie. You have really stable footage coming off of that thing. Oh, and it has another trick. The little pen pops out, and it's Bluetooth, so now I can start and stop my camera recording without bumping the phone, which is potentially kind of handy.
This elderly male Chinook is one of the last out of Saigon. He longs to return to the humid jungle and hopes he won't be abandoned in the desert like so many of his brethren.
So hopefully you found this interesting, but obviously, all these experiments, all of these tests are purely for educational value, to satisfy our own curiosity about the technology. You have no reason to be collecting data about the environment that is around you, the places that you live, at all. Just completely unnecessary, so just thought I would state that and, you know, get it out there. To change the subject completely, keep an eye out for next week's video, where we're going to be talking about the various companies and countries that are collecting data about you and your surroundings, and all the ways that they are mining it for value. In fact, I would say data is probably going to be the most valuable commodity of the 21st century. So yeah, that's next week's video. Keep an eye out for that. And in preparation, watch Clear and Present Danger.
Target is set. Start the music.
A quick FYI, if you do want to use the cheapest possible lenses and adapters for your Sony cameras, there are a couple of things to be aware of. And one of them is use a little file or something to clean up the hole that the retaining pin goes into so that it doesn't get jammed in there and have to be banged out with a hammer. It's always a fun thing to do with an expensive camera with an optically stabilized sensor.